together and we look at them in a smart way, and those applications, the one with great new technology, helping the people and driving the economy. Okay, so let me stop here about 5 minutes and take a move around before we move to the blackboard. Okay, here is, I'm going to start at the very basic level. Okay, so maybe some of you, I was just having a conversation here. Some of you may already see this material before. Okay, but some of you haven't seen it. But never mind. This is where the graduate level DSP course also starts. When I teach a graduate level course in DSP in the University of Illinois, we teach exactly this. Start from here. Two reasons. I hope this talk will help you. One is help you to familiarize yourself with the terminology in English. Right? So you can help you to read the material. Maybe you see it before in Vietnamese, now it's time to see it in English. Second thing, as I said, each thing we can teach at a different level, and if you can teach as difficult as English. So I'm going to try a very, very deep level, and the deepest level is when you will do the homework. Okay, that is where you can try to really test your understanding. Okay, so let me start. In DSP, okay, I'm going to use digital signal processing, DSP. It has only two characters. So the first one is signal. Okay, can you see that in the back? Okay. Second character, you only need to know two things in DSP. Okay. First is signal, and the second is the systems. Okay. So we only need to know two things: signal and system. Signal is many signal and many systems. In signal, roughly there's two types of signal. So we could have so-called okay, by the way, I would highly recommend you to take note. Okay, that's how I learn. When I sit in a lecture, I try to copy what the lecturer is writing and maybe note some more questions. Right? At least that's how I learn. Keep me stay awake. Okay, I hope you can help me too. Okay, the first thing is continuous signal, and example for it is XP. So it is something like we have a count or a variable, and we have a signal variable. Right? So that is a continuous. Sometimes it's known as an analog signal. Okay, that's something you probably heard. And the second one is a discrete signal. And the discrete signal, so here T is a real number, okay, a continuous variable. And the second one, the discrete signal, and here N is an integer. Okay? So that is a discrete signal. And the discrete signal, sometimes you could have a signal like those four. So the signal here is N0, 1, 2, 3, and so on. So the signal is discretized, okay, or it's sampled. Something we'll learn much more later. Okay, so there's two types of signal. Now, well, there could be a third type. Is after you have a discretize along this line, you may want to discretize along this line. And that will quantization process. And that way you have a digital signal. Right? Because on a computer, everything is all digital. But I'm going to mainly focus on these two types and ignore this quantization effect. And for that, in the US, people would call the discrete time signal and the digital signal at the same thing, even though it's not correctly. Okay. So far, okay? So remember two types of signal. Systems. System, loosely speaking, it's just something you can treat as a black box that can input in the signal and output is also a signal. And we have a system S beside that. Okay. And the thing about that here is I take the whole signal, okay, whole signal input, I put through the systems and turn out to be another whole signal. Not just a set, not one number, not just one value, but a whole signal. Okay, signal can be just a function or a sequence of number. Okay. So maybe we take some example here. Let's take an example. Okay, so one signal I can see here is the impulse signal. Impulse signal. And it's a very important signal, very important signal. So you have a name. So we will put the signal delta n here. So I have a special letter denoting that signal, delta. Delta n here, the signal here, and we define it is equal to 1 when n equal to 0 and 0 else. Okay, so that's the impulse signal. We can block them out. Block them out as signal 0, 1, 2, so on. So here the n, it can be have minus 1 so on. Everywhere else is 0 except there's one impulse. So that's why I call it impulse. Okay? So that's one. Now how about systems? The systems, so let me give you an example of systems. Okay. For example, I have a system and I can write y of n is equal to, so I have a systems here. So you think about it, I have an output here. I have an output here and I have to specify how can I compute this output based on my input. But also, what I have is a signal based on previous output. Okay, so get an example here, maybe equal to, so I take this signal, maybe I can start with two examples. So one signal is simply equal to summation n go from, so k go from 0 to n minus 1 of x n minus k. And then the whole thing here divide by n. Okay. Everyone have an idea what that system is? Taking what? Average. Right? I'm taking the average. What I have here is I take the n sample from n minus 1 to n minus 1. I take them sum and I take average. Okay. So this thing you can see later on. For example, when people look at the stock index, right, and they can go up and down very widely. But simply you take the average of the wick, for example, n equals 7. You can plot them out much more smooth. Okay, and we have to understand later on why the simple operation smooth out the signal. Okay.